Hello students, I welcome you all on my YouTube channel. From today onward we are going to start real analysis, right? So syllabus of real analysis has been divided into the four section. Okay, in first section we will be dealing with real numbers, real analysis. Okay, so in first section we will be dealing with real numbers, right? And in second section B, in this section we are going to cover sequences, and in third section we will see what are series and how to deal with them, how to find out sum, and how to find whether or not a series is convergent. And in last section, that is section D, we will be dealing with uniform convergence and power series. Okay, and power series, right? So firstly we are going to start from section B, sequences, because this is quite easy topic, so it would be pretty easy for me for you to understand this real analysis thing, right? So as name is suggesting, real analysis means analyzing we in this series we are going to analyze real numbers, right? So real numbers, or you can say real functions. Okay, like sets and all, we will be sets of real number, functions on real number, such sort of things will be coming in the coming in the picture in this series, right? So as I told you earlier, we are going to start from sequences, right? So today's topic is sequence. Okay, so firstly I'm gonna tell you what is a sequence. Okay, we have studied sets, we have studied function in elementary classes, right? So now we are going to study what is a sequence. Okay, sequence is also a function. Okay, sequence is a special type of function. Okay, what is special in it? So special in sequence is a sequence, a function from natural number to real number is known as real sequence. Okay, right? So it is a function from natural numbers to real numbers. For example, if you define fn is equal to n square, right? So here n is natural number, right? So you can see from here f of 1 is equal to 1 square, that is 1. F of 2 is equal to 2 square. F of 2 is equal to 2 square is equal to 4, right? And f of 3 is equal to 3 square equal to 9. So in this way it goes on like this, and we get a number, we get a set of numbers, right? 1, 4, 9, 16, 25 up to so on, and we call this set sequence. Okay, sequence of numbers, real numbers, right? So basically it is nothing but it is a function from natural number to a real number, right? And this is a kind of range of this function, or we can say range of sequence. Okay, or we can call it simply sequence. Okay, sequence, right? And sometime we used to write f of 1. Okay, f of sometime, or most of the time actually, most of the time f of 1 is written as a1, and f of 2 is written as a2, right? And f of 3 is written as a3, and so on. Okay, so in this way we get a sequence A1, A2, A3 up to so on. Okay, because here domain is a natural number, so this is a sequence, right? Sequence of real number, or simply we used to write this sequence in this way, an. So this is the how we represent sequence. If you get something written in your book in like this, then it means nothing but it means sequence. Okay, sequence an, and there will be defined that an is a sequence where an is equal to n square, as it was as I defined fn earlier, right? So this is the way how we write sequence. Okay, so one more example we are going to take to make it clear, right? Let us take one more example. So another example, okay, here fn is equal to 1 by n. Okay, or you can alternatively you can write it as an is equal to 1 over n. Okay, so as we will be understanding the concept, we will be not using this notation. Okay, this will be the notation we are going to carry forward, right? So an is equal to 1 upon n. Okay, so what would be a1 here? It would be 1 only. What would be a2? It would be 1 over 2. And what would be a3? It is 1 3, and a4 is 1 over 4, up to so on. So in this way we get a sequence 1 by 2, 1 by 3, 1 by 3, 1 by 4, up to so on. Okay, so this is the example of another example of sequence, right? So sequences can be bounded, sequences can be unbounded. Okay, now you will be thinking, what is this bounded and unbounded thing, right? So let me just write it over here. Okay, what is unbounded and bounded sequences? Okay, bounded and unbounded sequences. Okay, so firstly let us look at the boundedness of the sequence. So one definition I'm going to write over here. A sequence is said to be bounded above. Okay, is said to be bounded above. Okay, bounded above, not simply bounded but bounded above. किसी sequence को bounded above कब कहा जाता है? When, okay, a sequence is said to be bounded above if all the terms, okay, if all the terms of a sequence, all the terms of a sequence are lesser than a fixed real number. Okay, are lesser than, okay, yeah, smaller than, okay, smaller than a fixed number or real number. Okay, fixed real number k. Okay, that is all the terms. Okay, a1 is less than, must be equal to, less than, equal to, okay, lesser than or equal to, less than equal to k. ठीक है, and a2 must be also less than equal to k, a3 must be also less than equal to k, up to so on. All the terms must be smaller than or equal to k, right? So then we call this sequences bounded above, क्योंकि ऊपर वाला एक बाउंड है, इससे ऊपर सीक्वेंस जा नहीं सकती है, k से ऊपर सीक्वेंस जा नहीं सकती है, because all the terms of the sequence is lesser than this k. So that's why we call it, this sequence is bounded above. Or we used to write this in this way, in, okay, an if, that is an is less than equal to k for all n belonging to natural number. Okay, Okay, in one go we are going to write this in this way. Okay, if this is happening, all the terms, okay, of a sequence is less than or equal to k for all the natural number, then we call it we call this sequence as a sequence bounded above. Okay, similarly a sequence is said to be bounded below. Okay, bounded below if all the terms of a sequence are greater than or equal to, okay, or equal to, greater than or equal to a fixed number, greater than a fixed number. Okay, here say h. Okay, अगर सारी टर्म इस सीक्वेंस की h से बड़ी है, then we call this sequence is bounded below. Okay, that is h is, okay, an is greater than h. Okay, for all n belonging to natural number. ठीक है, सारी टर्म्स, इसका मतलब सारी टर्म्स a1 a2 a3 are greater than equal to h. Okay, so now I'm going to define what sort of sequences are known as bounded sequence. Okay, bounded sequence. Okay, a sequence which is bounded above as well as bounded below. Okay, a sequence which is bounded above as well as below is known as bounded sequence. A sequence which is bounded above as well as bounded below is known as bounded sequence. Okay, that is, इसका अपर बाउंड भी होगा और लोअर बाउंड भी होगा. सी, दिस थिंग इज नॉन एज लोअर बाउंड. ओके, और के को क्या बोलेंगे, अपर बाउंड. ओके, सो इसका दोनों साइड पे बाउंड होगा. ओके, सो ए एन इज लेस देन इक्वल टू के एंड ग्रेटर देन इक्वल टू एच. अगर ऐसे होगा, हर टर्म इन दो नंबर के बीच में लाई करेगी, देन वी कॉल दिस सीक्वेंस बाउंडेड सीक्वेंस फॉर ऑल एन belonging to natural number, right? So this is how we define bounded sequence. A sequence which is bounded below as well as bounded above is known as bounded sequence. That is, an must be less than equal to k and it must be greater than equal to h for all the natural number. Okay, so what sort of sequences will be called unbounded sequences? Unbounded sequence, simply a sequence which is not bounded is known as unbounded sequence. Okay, which is not bounded is known as unbounded sequence, right? So this is all about a bounded and unboundedness of a sequence. Okay, now let us take some examples, okay, to make it clear, make this concept clear. Okay, so take an equal to, okay, one examples to show how a sequence, how we prove that a sequence is a bounded. Okay, so an is given equal to -1 raised to power 1. Okay, this only. Okay, so you see, what is a1 here? Obviously a1 would be -1 power 1, which is equal to -1, and what would be a2? A2 is equal to -1 raised to power 2 is equal to 1, and a3 again it is -1, and a4 is equal to +1, right, up to so on. So what is sequence here? Sequence is -1 1 -1 1, and minus 1, okay, so on. Okay, we are just having two numbers here, 1 and minus 1. So obviously, see, this an is less than equal to 1 and greater than equal to minus 1, right? So see here, so this all the terms of this sequence, minus 1 1 minus 1 1, these are lesser greater than minus 1 or equal to minus 1 and lesser than equal to minus plus 1, right? So therefore we can say this sequence is a bounded sequence, or you can also say this an is lesser than 2, right, and greater than minus 2. Okay, so obviously this is also, in this way you can also prove that this is a bounded sequence, right? So pretty easy to prove that how that this sequence is a bounded sequence. Okay, one more example. If an is equal to, okay, no need to write bracket. Okay, so minus 1 power n upon n. Okay, so here you see what is your a1 is equal to minus 1 over 1, right? So it is minus 1. And what is a2 is minus 1 power 2 divided by 2, which is equal to 1 by 2, right? And what is a3 here? a3 is equal to minus 1 power 3 divided by 3, and it is equal to minus 1 by 3. And what is a4? a4 is 1 by 4. Okay, so in this way we get all the terms of this sequence. So this sequence is minus 1 half minus 1 by 3 and 1 by 4 minus 1 by 5 up to so on. If you see exactly this sequence, okay, first term is minus 1, second term is minus 2, and this term is minus 3, okay, and then 1 by 4 minus 1 by 5, then 1 by 6. Okay, so this sort of terms you are getting in this sequence. So obviously you see in both the way this term is, and the sequence is decreasing, right? So it is decreasing here also. Okay, you see if you draw it on real number, real line, so how, see, okay, so this is your real real line, and here lies minus 1 and here is 1, right? So this is the a1, right? And what is your a2? a2 is this number, half. Okay, so it is 0. Okay, so a2 is somewhere here. Okay, it is half. Okay, a2. And what is a3? a3 is 1 by 3, so it is somewhere here, minus 1 by 3. Okay, a3. And what is a4? a4 is 1 by 4, so it would be half of half, it is somewhere here. Okay, so a5 again, so it would be somewhere here. Okay, a6, it would be somewhere here. Okay, so in this way you see from both the side it is approaching towards 0. So we can say this, all the terms of this sequence is greater than minus 1 and lesser than 1. Okay, so we can write it as that an is less than equal to 1 and greater than equal to minus 1. देखो इसकी कितनी भी जितनी भी टर्म होंगी सारी माइनस 1 से ग्रेटर ही होंगी, राइट? बिकॉज माइनस 1 इसमें सबसे स्मॉलेस्ट नंबर है ना, और यू कैन से, और 1 by 2 इसमें सबसे बड़ा नंबर है, तो 1 उससे भी बड़ा हो गया. तो इन दिस वे यू कैन से दिस सीक्वेंस इज लाइंग बिटवीन minus 1 and 1. Therefore you can say this sequence is bounded sequence, and this is your lower bound. Okay, and this is your upper bound. Okay, so these are the two bounds of a sequence. Okay, so I hope you get it. Yeah, so now we are going to take some more problems, right, to make you clear. Okay, so one more problem. Okay, example, a sequence is an where an is equal to 2n minus 3 divided by 3n plus 7, right? So this is the sequence. Okay, so see here we are going to solve okay, we in this video in this problem we will be solving this problem and by little different method. Okay, how we are going to do this? Firstly, we are going to divide 2 3 minus 1 by 3n plus 7. Okay, and let us see what we are going to get. So if you want to divide, so you want to get here 2 by 2n, so you will have to multiply it by 2 by 3. Okay, sorry, yes, okay, if you multiply it 2 by 3, so what do you get? Okay, so in this way you are going to get 2n over here and 2n over here and minus 14 by 3, right? So this gets cancelled and you are having 14 by 3 minus 3, so it is equal to 14 minus 9, which is 5 by 3. Okay, I'm sorry, it is plus, right? So it would be minus, so minus. Okay, so 14 minus 14 plus minus 14 minus 9, which is equal to minus 23 by 3. So okay, so this is your remainder. Okay, and this is your divisor and this is your quotient. Okay, and r. So if we write it in, we can write this thing in this way. Okay, firstly you are going to write quotient, okay, plus remainder is 23 by 3 upon 3n plus 7. So okay, so this is the way how we write it. Okay, it is pretty simple. Don't get confused in this. Like if you are dividing 8 by 3, okay, so 2 multiplied by 2, so we get 6 over here and 2 as the remainder. Okay, you just take 10 here. Okay, so 10 or you take to differentiate the numbers, I'm just writing it 14. Okay, 14 13. Okay, 13, right? So you will have to multiplied it by 4, so in this way you are going to get 12 and 1 is the remainder. So we can write this number as 4 whole, okay, 1 by 3 or 4 plus 1 by 3. This is the same thing. Okay, 4 whole 1 by 3 or 4 plus 1 by 3. So same thing we are going to write, same thing we have written over here. Okay, so now you see an is equal to this. Okay, so it is equal to 2 by 3 minus 23 by 3, or you can write it as 23 by 3 into 3n plus 7. Okay, so this is your an. Okay, in alternate form, or alternatively you can write an is equal to this. So now you see something is okay, something we are subtracting something from this number. Okay, अगर हम इस नंबर को यहाँ से हटा दें, ठीक है, ये इससे वैसे भी माइनस हो रहा है, ये पूरा नंबर यहाँ से यहाँ तक का नंबर कम कर रहा है क्योंकि ये सब्सट्रैक्ट हो रहा है. सो अगर हम ये वाला छोड़ दें तो ये वाला नंबर क्या हो जाएगा, बड़ा हो जाएगा. ओके, सो ए एन वुड बी ग्रेटर. ओके, सो वैसे ए एन इज इक्वल टू दिस. ठीक है, सो इफ वी लीव दिस नंबर, राइट, वन सेकेंड, okay, so an would be lesser than 2 by 3. Why? See, I'm going to make you understand this with the help of example. Okay, for if an is equal to 4 minus 2, for example an is equal to 4 minus 2, okay, right, that is an is equal to 2 here. Okay, simply I'm just writing 2 equal to 4 minus 2. Okay, so an is equal to 4 minus 2, so I can write, if I remove this minus 2 from here, okay, so this an, that is 2, is less than 2, right, less than 4, sorry. Okay, so if I remove this 2 from here, this an, which is equal to 2, will be obviously lesser than 4. That is, when we remove such terms which are occurring after minus sign, okay, it makes this inequality. Okay, okay, so that's why I'm writing an is less than equal to 2 by 3. Okay, it may be equal also, it may be less than equal to 3, 2 by 3. Okay, so this is your upper bound is 2 by 3. Similarly, you see what is your an is equal to not similarly, you just see now. Okay, if an here is equal to 2n minus 3, 3n plus 7, right, this is your an. Okay, so see what is your a1. So a1 would be 2 minus 3 divided by 10. Okay, so which is equal to minus 1 by 10. देखो इसमें सिर्फ एक ही टर्म होगी माइनस में, वो कौन सी होगी, an. ठीक है, क्योंकि बाकी अब a2 क्या हो जाएगा, a2 हो जाएगा 4 minus 3 which is 1 divided by पॉजिटिव. ओके, और नेक्स्ट टर्म कितनी हो जाएगी, देखो यहाँ पे लिख ही देता हूँ मैं. ठीक है, सो a2 इज इक्वल टू 1 बाई 13, राइट, एंड a3 अब कितना हो जाएगा, ये और ग्रेटर हो जाएगा 6 माइनस 3 विच इज इक्वल टू 3 डिवाइडेड बाय 16. ओके, एंड व्हाट वुड बी a4 वुड बी 8 माइनस 5, एंड ठीक है, दिस विल बी इंक्रीजिंग कंटिन्यूसली. ओके, माइनस 1 1 3 5, अब 7 हो जाएगा. नाउ ऑल द टर्म्स आर ओके, ऑल द टर्म्स आर पॉजिटिव. ओके, सारी टर्म क्या है, पॉजिटिव, एक्सेप्ट दिस. तो वी कैन राइट कि an इज ग्रेटर देन माइनस 1. ठीक है, और यू कैन राइट an इज ग्रेटर देन इक्वल टू माइनस 1 बाई 10. ओके, और इक्वल लगाना पड़ेगा फिर, क्योंकि एक टर्म इसके इक्वल है. ठीक है, तो an इज ग्रेटर देन इक्वल टू माइनस 10, और यू कैन सिंपली राइट ओके an इज ग्रेटर देन, ऑलवेज ग्रेटर देन माइनस 1, क्योंकि ये वाली एक ही टर्म नेगेटिव में है और वो भी 1 से, ठीक है, ग्रेटर है. ओके, एंड ऑल्सो इट इज लेस देन इक्वल टू 2 by 3. सो in this way we get that this sequence is bounded, its upper bound is 2 by 3 and lower bound is minus 1. So this is how we prove boundedness and unboundedness, right? So now nextly we are going to talk about least upper bound. Okay, least upper bound. Okay, so we saw in the last example that an was here lesser than 2 by 3. Okay, so 2 by 3, it means it is 0.6, right? So if an is lesser than 2 by 3, it means an must be lesser than 1 also, an must be lesser than 2 also, an must be lesser than 3 also, up to so on. So these all numbers are known as upper bounds. Okay, these are upper bounds of this sequence. Okay, upper bound of this sequence, right? So इनमें से जो सबसे छोटा होगा, जो सबसे लीस्ट होगा, लीस्ट among these upper bound is known as least upper bound. So least इसमें से कौन सा है, ये वाला नंबर, सबसे छोटा अपर बाउंड, सबसे छोटा अपर बाउंड is known as least upper bound. Okay, so this is the least upper bound here. Okay, so definition, how we will be defining this. Okay, you see, definition of least upper bound. Okay, LUB, this is also known as supremum. Okay, supremum, let me write supremum. Okay, supremum. So definition of least upper bound. Okay, so I think definition आपको लिखने की कोई ज़रूरत नहीं है. Okay, you just see it is just the least among the, okay, an upper bound, you just write. Okay, an upper bound U is known as least upper bound if it is least, okay, or smallest among the all upper bounds, okay, of a sequence an. Okay, you just write it here, an upper bound U of an. Okay, of an, इस ब्रैकेट में लिख लो या फिर इस ब्रैकेट में लिखो, दोनों ब्रैकेट सीक्वेंस ही सिग्निफाई करती है. ठीक है, सो किसी एनी अपर बाउंड ए यू इज नॉन एज लीस्ट अपर बाउंड इफ इट इज लीस्ट और स्मॉलेस्ट अमंग द ऑल upper bounds of that sequence. Okay, properties of this upper bound. Properties, these properties are very important. Later on we will be using these properties in the results we are going to prove on this sequence, okay, on the sequences concept of your lecture, of your interest. Okay, so now, so first property is an is always lesser than or equal to u. Okay, for all n belonging to natural number. Obviously, ठीक है, ये क्या है, अपर बाउंड है. अपर बाउंड होने का क्या मतलब होता है, all the terms of a sequence must be smaller than this upper bound. Okay, it is quite simple. ठीक है. सेकेंडली, दूसरी मेन प्रॉपर्टीज की जो है, इफ अगर मैं कुछ भी छोटे से छोटा इसमें से माइनस कर दूं, ओके, इफ आई सब्सट्रैक्ट एनीथिंग however smallest from this number will be no more upper bound. Okay, अगर मैं कुछ छोटे से छोटा, जितना छोटा भी इसमें से माइनस कर लूं, ठीक है, कुछ भी छोटा से छोटा माइनस कर लूं, देन इट वुड बी नो मोर अपर बाउंड. ओके, दैट इज an is greater than equal to u minus epsilon for some, okay, for some, okay, for some n. Okay, you just write for some n, right. अगर इसमें से मतलब कुछ मैं सब्सट्रैक्ट कर दूं इस लीस्ट अपर बाउंड में से, ठीक है, तो ये अपर बाउंड नहीं रहेगा. इसका अपर बाउंड नहीं रहने का मतलब क्या है, कोई ऐसी टर्म होंगी सीक्वेंस में जो इससे बड़ी होंगी. ऑब्वियसली दिस इज व्हाट वी मेंट बाय द by a number which is this is what we meant by what is not a meant by a non upper bound. Okay, thing. So yeah, so this is it. Okay, right. So these are two properties of upper bound, right. अगर इसमें से कुछ छोटे से छोटा माइनस कर दें, it would be no more an upper bound. Okay, similarly let us define what is lower bound, greatest lower bound. Okay, greatest lower bound, it is also known as infimum. Okay, infimum. Okay, so as we did earlier, okay, greatest lower bound, ठीक है, we saw an was less than greater than equal to -2 and less than equal to 2/3. ओके, सो देखो ये क्या है, लोअर बाउंड है. ये वाला सीक्वेंस -2 से भी बड़ा रहेगा, -3 से भी बड़ा रहेगा, -4 से भी बड़ा रहेगा, -5 भी से भी बड़ा रहेगा. ठीक है, these all are what? These all are लोअर बाउंड्स. These are लोअर बाउंड्स ऑफ an. ठीक है, इसमें से सबसे बड़ा जो होगा, ठीक है, इसमें से सबसे बड़ा नंबर इज नॉन एज ग्रेटेस्ट लोअर बाउंड. सो दिस इज द ग्रेटेस्ट अमंग दीज. ओके, 1 2 3 -5 तक, इनमें से सबसे बड़ा कौन सा है? -1. सो दिस इज द ग्रेटेस्ट लोअर बाउंड इन दिस केस, राइट. सो सबसे बड़ा लोअर बाउंड is known as greatest lower bound or infimum, right? So again some properties of this greatest lower bound. properties, क्या properties होंगी? Similarly उसकी तरह lowest upper bound की तरह first property is, देखो ये lower bound है, इसका मतलब क्या है? an क्या होगा? देखो lower bound को हम represent करेंगे L से. okay, so all the terms of a sequence would be greater than this lower bound L for all n belonging to natural number. Second property, अगर मैं कुछ इसमें प्लस कर दूं, ठीक है, if I add something to this lower bound then it would be no more a greatest lower bound, not even lower bound. ठीक है, अगर मैं कुछ इसमें ऐड कर दूं, ये फिर लोअर बाउंड भी नहीं रहेगा. ठीक है, तो इसका मतलब क्या है, अगर लोअर बाउंड नहीं है तो कोई ना कोई टर्म एग्जिस्ट करेगी जो इससे बड़ी होंगी. ठीक है, फॉर some n, right? So these are the two properties of greatest lower bound, right? So I think this is it for today. Rest of the things will be done tomorrow. Okay, thank you.